Hello! Today we're starting a new tutorial on numbers in Godot. In a new project, we create a control node. Name it number tutorial. Save it. Add a label. Center it. And add a big font size. Attach a script. Make sure to select the control node first. Now let's drag the label in the script. And we can access it through code. This will be useful to display results. We'll use the ready function. For now, just write pass. This basically means our method does nothing yet. And let's create an integer variable. The type is called int. Let's make it equal to 2. Now, if we control click on int, we get the documentation. 64-bit integer. It takes values from -2 to the 63rd till 2 to the 63rd minus 1. It's those two values over here. If we try to surpass them, it wraps to the opposite sign. Okay, first of all, we need to show our number. str is a function that changes values to strings. And now we pass number as an argument. Now we can see our number in the label. Now let's get the minimum value. Now let's decrease it by 1. That will make it wrap to the positives since there is no smaller number to go to. That is called overflow. Now we get the largest int. That's what wraparound means. We went from the smallest int to the largest. Let's see it the other way around. Now we add to the max value. We go to the negatives. In many cases, we limit the variable to a certain range. That way we don't run into overflow. Integers can also turn into float for methods. We'll see floats in the next video. The float will be as close as possible to the int. That is a precision error with computers in general. Let's say 1 could be represented as 1.000 and then 1 at the end. Sometimes floats don't represent the correct value. There will be an example in the next video. Floats can also turn into integers, but the decimal part gets truncated. Let's use a real number instead. That is valid, but number will be 2. We also get a warning. Narrowing conversion. Float is converted to int and loses precision. If we run it, we get 2 instead of 2.5. Anything after the dot gets removed. To see an example, let's say we have a spin box. This includes a number we can increase and decrease. Changing the font size is a bit more tricky here. We go to theme instead of overrides. Add a line edit theme. And select font size. Now we have it here. Let's change the step to allow float values as well. Now it shows 0.0. That's because it's viewed as a float. Create a non-ready variable for the spin box. And set the number to spinbox.value. The label contains 0, but the spinbox says 0.0. Let's change the value. In the edit I noticed I changed the minimum value, but that's not really a problem. The value changed as well. So back to the video. Our label says 1, but the spinbox says 1.5. Now if we want to get rid of the warning, we can click Ignore. And that adds an annotation above the line we're ignoring. That only covers the next command for narrowing conversion. This one is used to ignore a specific warning. We can also use ignore start. For example, let's add another command. Now we get the warning again. We also have unused variable, so let's fix that real quick. Okay, now it's just a conversion warning. We could either copy paste the one from above, or use the annotation start and restore when we're done. Now the warnings between the two annotations will be ignored. If we run it, we get 5, because we have 2 plus 3. The decimal parts are removed. We could also go to our project settings, find GDScript, and here we can see all warnings and errors. Here's the narrowing conversion. We can set it to ignored, and those should disappear. If they're still there, reload the project. Okay, now we get no warnings. Now let's bring it back. By the way, two warnings I usually enable are return value discarded and untyped declaration. We still don't have a warning. Oh, okay. We need a change on the script so that the engine will check for warnings again. Integers can also be used as booleans. it treats all numbers except 0 as true. We can see it here. In a Boolean context, an int will evaluate to false if it's equals to 0 and to true otherwise. Same goes for the float numbers. Now it shows the first number. If we change it to 0, that should be false. So instead of this, we run the else body. Now, we'll talk a bit about binary numbers, also known as base 2 numbers. Those are numbers that only use 2 digits and work very similar to decimal numbers. For example, 365 has 5 ones, 6 tens, and 3 hundreds. Those ones, tens, and so on are called place values. The binary number 1010 has 0 ones, 1 twos, 0 fours, and 1 eights. As you can see, we go with powers of 2 instead of 10. If we multiply each digit to its place value and add them up, we get the number in decimal form. 3 hundreds means 3 times 100, plus 6 tens, 6 times 10, and 5 ones, 5 times 1. We can do the same with binary numbers by using the classic addition and multiplication we know. Okay, let's use a binary number here. We type 0b in front of the binary. So 0b101 is 1 times 1 plus 2 times 0 plus 4 times 1. That is the number 5. This only allows zeros and ones. Anything else gives an error. Invalid numeric notation. Binary numbers are usually hard to read and calculate the base 10 value. So we put them in groups of 4 starting from the end and change them to base 10 numbers separately. If a group has 2 digits, we replace it with one of the letters below. So 10 becomes A. That way we spend less time to write the number. That's a base 16 number called hexadecimal. Just like with base 2, we have the 1s, the 16s, 256, and so on. We could also split a binary number in groups of 3 to get an octal number. But since Godot doesn't support that, at least for now, we won't be seeing it. The notation is 0x. So we replace b with an x. Now we can also use the letters A to F. This symbolizes the number 10, so we have 10 times 1 plus 1 times 16, which gives us 26. Again, the notation is limited to digits and the letters A, B, C, D, E, F. G, for example, gives the same error as before. Okay, finally we have the underscore. This one is to separate the digits of large numbers. Let's say we have 1 million. Instead of counting the zeros, we place underscores. Now it's easier to read the number. Just like the other notations, this is for the programmer's eyes. The number won't keep the underscores. Okay, this is it for integers. In the next video, we'll move on to float numbers. Till next time.